game day at Rapid. It's really exciting to be here in person with Shawn Springs, CEO of Windpact, and Ed Herderick from Ohio State University, the CDME. So we're going to talk about what you're doing, all the exciting things you're doing at Windpact, and would love to hear it.
Yeah, and I'm excited because I get to be with one of my favorite advisors, the scientist, Dr. Herderick, from the Center for Design, Manufacturing, and Excellence at Ohio State. And it's always important that we say Ohio State because that's kind of the foundation of like kind of prepared me to be the CEO of Windpact. And today, Windpact is a technology and material data company. We supply the critical data to these designs and analysis tools so people can run simulations. Basically, you know, for me, the journey started with how do I make the game of football safer? Obviously, I played 13 years in the NFL. And I was looking at some of the technologies out there in foam, and we started off as an ingredient brand, working with companies to make better sports equipment, better products that absorb and disperse energy. But we quickly realized that, you know what, we're starting to get really good at our process of characterizing these materials and starting to be smarter around how the materials perform. And working with guys like this who make you look good always.
Well, and I think the fun thing is, it's like, okay, so I've been at Ohio State for 4 years now.
Yep.
And we met probably right when I came back to Ohio State.
Yep.
Of course, it's my alma mater too.
Yep.
And we met through a mutual colleague, Dr. Jay Sayre,
Yep.
who's a material scientist at the Institute for Materials Research, IMR at Ohio State, and longtime collaborator and advisor for Windpact.
Yep.
And it was just really fun because we started talking, and Shawn has this passion for material science, which of course has been my career passion. And then, right, because you were starting out with the foams, and then we started talking about additive manufacturing, 3D design, lattice structures.
And Ed told me about it. He said, you know, another viscoelastic material, you should look at lattices. I said, sure.
Yes.
Great.
Well, and the fun part has been too, right? So at CDME, we're all about experiential learning. So we have undergraduates in the lab that are doing projects. So we've had a couple of undergrads that have done some lattice design and end topology, done printing with the Formlabs printers. Now they're testing some things. So it's really come full circle, right? I mean, it literally started with like a cup of coffee, talking about material science.
Yeah, and Ed talking about football.
Yeah, I was talking about football. You're talking about material science.
I'm asking him questions about football. He's asking me questions about how to play football. So it kind of worked out. It was like a...
that was through, well, no, because we were over at Hudson 29, remember
that's
that?
Right, that's right.
And then we went to, we saw the Chase Young, Wisconsin game in the rain.
So you see the history there. But really the synergies are how everything ties together.
Yes, yeah. So what are some things that you're looking to do right now based on where you're at and where you're trying to go with the product?
Yeah. So one, coming in Rapid, you know, it's my first time being here. And I know we have engineers that went to AMUG and some other conferences, but I'm just blown away just by the space. I tell Ed all the time, I put it in, and I tell you about our business, but I tell Ed as I start to look at, you know, we started off in foams. We know that pretty well. But when you start to think about what's happening and the applications that 3D printing can present, like how you can even optimize even further beyond what you could do with the foam materials, I'm just blown away by some of the software companies that are here, some of the other companies or 3D printers that are here, from people talking about tungsten materials to all type of plastics and other things I don't know their real names about, but it's really, really cool things, and it's a world of possibilities, you know. And for us, collecting that data, collecting that type of information helps us even help our customers even solve problems even better.
Yeah. And your customers, you have a wide range of customers that you're supporting right now.
Yeah, so we started off with, like I told you, we started off in the sports space where we were looking at what type of impact materials absorb and disperse energy. One of our patented technologies, crash to absorb and disperse energy, and putting that into different applications, from baseball helmets, was one in the Olympics, to headrests for Tier 1 automotive, to working with the Department of Defense for the last 3 years now, looking at ballistic impacts on the new shells and everything. So, and it's pretty cool because now, you know, I always have the opportunity to leverage the world's smartest scientists, I believe, to enhance these applications, and I think these are people who can solve some of the most difficult challenges like concussions or traumatic brain
Right.
injury that you see in sports.
Sure. Sure.
Yeah, I think the interesting thing from a materials and design perspective is these are really, really difficult challenges,
Yep.
right? Because, so if you look at the end user, whether it's a war fighter, whether it's a race car driver, whether it's a high school football player, right? They want the lightest, leanest, lowest profile technology you can give them, right? Whereas literally the opposite is true for the energy impact. The more material you put in, the more energy you can absorb.
Right.
And it occurs across different time scales with these impacts, right? I mean, it's like microseconds to milliseconds.
Yep.
And across length scales in material science, which is what really brings in additive and makes it fun. Because it's like, okay, so we're doing things like with graphene and carbon nanotubes at the nanoscale up through these lattices that we can make at the micro to millimeter scale,
Yep.
up to full scale parts that are, they're feet or even meter. Like you look at a race car, right? Can we print all the pads for a race car driver
Right.
in a car? I mean, the answer is probably in the future we will be doing stuff like that.
Yes.
I mean, those are the kinds of things that we're developing.
Yeah, and I think for me, as a former athlete looking in, talking to Ed about, the customization, right?
Exactly.
You're talking about, prosthetics or orthotics in the shoes. As an athlete, you're always thinking about, it's one thing to protect, but how does it fit?
Yep.
How does it feel? And I'm always challenging Ed, like, what's the future going to look like? How are we going to get these things not only lightweight and still have the performance you're looking for, but the fit and feel? What type of materials out there is best for that?
Yep.
So.
And at scale. I mean, that's where I think additive. So I've probably been in an additive for like 10 years, or something like that, right? And a lot of it we did it together, Georgette and I. But,
Known a long time.
yeah, but it's really an interesting time for the additive community because in a lot of ways it is mainstream, but it's really, now it's that applications engineering. It's delivering the performance, not just one time in a prototype, but thousands of times over and over. And look, I mean, we're seeing it. I mean, it's not just aerospace now, it's getting into consumer products. At CDME, we're doing a lot of biomedical devices now, right? We're doing custom patient-specific models and cutting guides, things like that. It's just a really fun time. It's a great field, it's a fun time.
It's exciting to see these different applications that you're highlighting here, and things that we watch every day, right? Like that we don't realize what you're dealing with as an athlete, and making things better and safer for them. So I really appreciate the time of both of you and all the exciting stuff Windpact's doing.
Thank you.
Thanks.
Georgette.
Thanks, Ed.
Thanks, Shawn. OH. All right.